Everyone, here in this video we're going to be talking about some more universal functions. In previous video we understood what universal functions are, and here we're going to be talking about some more universal functions which are frequently used. Now the first of those are rounding. We're going to see how can we round these all numbers. You see here we have two lists, one is my list, the other one is your list. It's just a name, don't go by this. Okay, so here we have these all options which we can use to round it off. Okay, so first one is truncation. What happens in truncation? So okay, before we start, it is important that you import the NumPy library. Here I have imported NumPy and I have given an alias of np to this NumPy module. Okay, now I'm just going to truncate the values in my list. Okay, so what I'm gonna do is when you do the truncation, it will simply remove the values after decimal. Okay, how can we do that? For that you're gonna say np.trunc, and in that you provide the list to which you want to truncate. You see here we got that. The other function which does the same thing is fix. np.fix, and you provide the same list, and here you got the same result. The other function here, you can specify to what number of decimal values you want to round it off, right? For example, here we have 4 digit or maybe even more than 4 digits after decimal. Now if you want to round it off to 2 digits, how can you do that? For that you're going to say np.round, and in that you provide the list which you want to round it off, and then here you got that. So because here we didn't provided any value, that's why it is working as the truncation. So here you're gonna, if you want to round it off to 2 decimal places, then you're gonna put 2 over here, and you got this. Okay, if you want to round it off to till 3 digit, then you can do this as well. So this is how you can do the rounding. Now if you want, you can find the lowest, the nearest lower rounded number. What does that mean? Let me try to explain you. For example, here I say my list. Now if you see, this value is 4.09. now what is the nearest lower rounded number? So that will be 4. Here it will be 6. So similarly, if you want to do that, how can you do that? For that you're going to say np.floor, and in that you're going to supply the list, and this is what you get. I just hope that it is clear to you. In case of doubt, put that into the comment section. Now if you see the third element, what is happening, it is flowing down to 3, -3. Okay, why is that so? Because it is very near to 3, that's why it is doing that. Now in floor it brings the value to downward, right? In cell it takes to upward. What does that mean? Let me print the my list first and then I will show it to you. Okay, so here if you see 4.09876. now if you do np.floor, what you get is 4, right? For this particular value you are getting 4, but if you do np.cell, then what you're gonna get is, let's see, here you get 5. That means it is taking to the next rounded number. Floor takes to the previous rounded number, and cell takes to the next rounded number. So that's how it works. Next we go and find the logs. When you are working in mathematics or something like that, you got to find the logs as well. How can you find that? For that you're going to say np.log, and in that you supply the value, let's say my list. Let's see if this works, right? And then just hit enter. Okay, so this is giving you the log value. Now if I want to find log 2, then I gonna say log 2. So by default it gives you the log 2 only. Now if I want to find log 10, so simply you need to say log np.log10 and supply the list, and then you get the log 10. So this is how the log works into the NumPy. Next thing which we're gonna learn is summation. How does summation works? Okay, so let's say here we have 2 arrays created over here. Now if we want to add both of these 2 arrays, how can we do that? In previous videos we learned we can use universal function np.add, but what happens when you use this? Let's try to add array 1 and array 2, and let's see what happens. So it is adding each of the element right? And then it is giving you another list with same number of elements. So in array 1 we have 4 element, in array 2 we have 4 element, and it is adding 5 with 1 which is 6, then 2 with 6 which is 8, and it is giving you a resulting array with the same number of element which is 4. Now let's see what happens when you use summation. Okay, so in that np dot, when you use sum and when you supply array 1 comma array 2 and then you hit enter, something wrong has happened. Let me just do this thing. Let me just supply one array only. Okay, so if you see over here, if you look at this, okay, what exactly is happening, try to understand. So it is simply adding each of these value together, right? It simply adds each of the value in a provided array or list. So 1 or 2, 3, 3, 6 and 4, 10. This is how it is adding it. All right, I just hope that it is clear to you. Now there is another function which is called, this summation, another way of summing it up by axis 1, axis equal to 1. How that work? np.sum, and into that what we're gonna do is you supply array 1 comma array 2 and then you hit enter. It is giving you the error, and for that what you can do is you can supply the axis equals to 1, and then you see it is still giving you the error. For that what we're gonna do is let's put this way, right? And now if you see this, what is happening, we are getting 10 and 26, means 10 is the summation of first array, 26 is the summation of second array. Okay, this is doing that way. Okay, the second array is 5, 6, 11, 7, 18 or 8, 26. This is how it did. So here we added all the elements in each of the arrays separately, right? This is how summation works with axis equals to 1. Now let's say here we have array equals to, this first array, here we have the value 1, 2, 3, 4. Now what I want is I want to find the sum in a way like, say 1 and 2 it should become 3, then 3 and 3 it should become 6, then 6 and 4 it should become 10. That means I'm trying to find the cumulative sum. How can you do that? For that what we're gonna do is you're gonna say np dot cum sum, and in that you supply your array or list, whatever it is. Okay, and here we got that value, right? 1, 3, 6, 10. If you look at the array 1, so this is the value which you have, 1, 2, 3, 4, and when you find the cumulative sum, this is what you get. Same thing you can do to find the products as well, right? So let's say here I have array 1 and let's print it. Let's print this. Here we have array 1, and when you, if you want to find the product of this, let's see how does that work, right? And into that I'm going to say array 1. Let's see. So here it gives you the 24. That means it is multiplying each of the array together, each of the element together. Let's see. 1 2 is 2, 2 2 3 is 2 3 is 6, right? And 6 4 is 24. Now let's see how does cumulative product work, right? So for that what we're gonna do is we're gonna say cumulative product, and that what we get is this. That means it is multiplying each of the element and it is giving you same number of elements in another array. So here it multiplied 1 with 1, that is 2, sorry, that is 1, then 1 multiplied by 2 which is 2, then again 2 times 3 which is 6, and 3 times 6, sorry, 3 times 4, my bad, 6 times 4 which is 24. All right, so I hope this is clear to you. Now next comes, the next thing which comes is finding the difference, right? Let me print both of the array once again. Here we have array 1 which is this 1 2 3 4, next array which we have is 5 6 7 8. Now if we gonna do this particular thing, what we're gonna do is we're gonna find the difference. Let's see np dot diff, and in that if you provide array 1 comma array 2, let's see what happens. I don't know, it gave us the error. So what is it that we're gonna do next? Let me just put one array, and what you get is, so it doesn't perform, it doesn't find the difference between two arrays, rather it finds the difference between each of the element in one array only. Okay, so if you see here, we supplied array 1 and here the values are 1 2 3 4. So between each of the element in array 1 we have the difference of 1. Okay, so what it does is it subtract the previous element from the next element, successive element. Okay, so see, this next element is 2 and previous element is 1, so 2 minus 1 is equal to 1. Again 3 minus 2 equals to 1. Again 4 minus 3 equals to 1. Now after getting this difference, if you want to find the difference of this as well, then what you're gonna do is you're gonna say n equals to 2. So let me print that. Let me do this for you in the next shell. Over here let it be, and over here what I'm going to do is this. So here we found the difference between each of the elements which are available in array 1. Now whatever result you got, I want to find the difference between them as well. So in that case you're going to supply the next dimension, which is n equals to 2, the second times difference. So that's what you get. Here it is doing 1 minus 1 equals to 0, then again this one minus this one, again 0. Again it takes from the successive to the previous one. Now if you want to find the difference between both of these two also, then what you're gonna do is you're gonna supply n equals to 3, and this is what you get, right? So no matter how many elements you have available in one array, if you want to find the difference between all of them, and if you want to reduce them till 1, then you can keep on increasing the value of n. I just hope that it is clear to you. Just in case of any doubt, put that into the comment section, like I always keep on saying, right? Now here we're going to find the LCM, not difference. Here we are going to find the lowest common multiple of the array values, right? How can we do that? For that we're going to say np.lcm, and in that we're going to supply array 1. Let's see if this works on one array. No, it's gonna work on 2 arrays, right? So you're gonna supply array 2 as well, and this is what we get over here. Let me print for you array 1 equals to this. Oops, the spelling is wrong. Array 1 is this, and then array 2 is this, and when you find their LCM, this is what you get over here, right? 5 6 21 and 8. This is the lowest common multiple, right? Now there is another thing. Let me show it to you. np.lcm.reduce, and in that if you supply array 1, let's see what you get. Here you got that. So like if you want to find LCM for 2 arrays, you're gonna supply np.lcm. If you want to do the same thing on one array only, you're gonna say np.lcm.reduce. So for this particular one, for this array 1, the lowest common multiple is 12. Okay, all right, I just hope that it was clear to you. Now moving forward, we will move forward. Here we're gonna find the gcd, which is greatest common denominator. This is nothing but highest common factor, right? So how can we find that? The same way, np.gcd, and in that you're gonna supply array 1 comma array 2 to find the GCD for 2 arrays. So this is the greatest common denominator, okay? Now, or highest common factor we can say rather. Now after this, if you want to find it for one array only, the same thing you're gonna do, which is np.gcd.reduce, all right? And in that you're gonna supply the array value, which is this array 1, and for that the greatest common denominator is only 1. Okay, let's see what happens for 2. That's over there also the same story. Now if you want, let's see, can we change this value to the manual one? 4 8, let's say 16, and let's say 20. What is the result? That we got 4, right? So I just hope that it is clear to you and you understood this. Alright, so the next thing which we're gonna learn about sets, right? So here, let's say we have 3 lists. Now we want to find the unique values in the list. How can we do that? First, you're gonna say np.unique. Alright, here. And I'm going, like you can see in the list 1, we have the duplicate values, okay? Here it says 2 5 6 2 5 8. So what the unique value is? Unique value is 2 and 5. 2 is repeated twice, 5 is also repeated twice. So this is the way to remove duplicates from a list value, okay, or an array you can also say, right? So I'm going to say list 1, and here what you get is the unique value from that list. So this is how you can make the list pretty unique. Now the next thing which we're gonna find is union 1D. What does that mean? Let me try to explain you with the help of example. Here we have two lists, list 2 and list 3. If you see, there are some common values like 9 and 12 which is common in both of these two, and some unique value 3 and 6 and 15 and 18. These are unique in between both of these two, okay? So let's see what does happens when you say np dot union 1D and union 1D, and in that if you supply both of these two lists, which is list 2 and list 3, and you see what exactly happens is it concatenates, I mean it combines both of the lists but keeps the unique value. Like you see 9 and 12 was repeated, but here we have 9 and 12 only once. So here it is making a union of two lists, right? Whatever unique value is available, it is simply putting them in the result, okay? Now I just hope that it is clear over here. So if I have to explain you again, 3, 6 is taken over here, 15 and 18 is taken over here. Now 9 and 12 both are common in both of these two, so one set of 9 and 12 is taken only, okay? Now here we're gonna find the intersection of both of these two. How does that work? Let's say intersect 1D, and in that you're gonna provide list 2 comma list 3, and when you hit enter, so this provides you the value which is common in both of the list, like 912 and here 912. This was common in both of the lists, so that was the intersection point, right? So that is resulted when you use this function intersect 1D. Next one which we're gonna learn about is this one, set x or 1D. Let me tell you what does that mean. Set x or 1D, and in that if you supply list 2 comma list 3, and when you see the result, this is what you get. This is just related to this but little different from this. In this what is happening, it is wherever it is duplicate, it is just keeping one set of that, and in here what it exactly doing, it is removing the values which are common between two lists. Or maybe we can say that it is opposite to this one. When you say intersect, in that what it is doing is it is producing the common values in both of the lists, and here it is producing the values which are not common in both of the two lists. So when you do intersect, it produces the value which are common in two lists or in two arrays. When you use set x or 1D, then it produces only those values which are not common in both of these supplied list. So this is it for universal function list. I just hope that it was clear to you. Just in case if you get any doubt, put that into the comment section. And sorry for this long video, I just tried to cover all of these frequently used functions in one video, that's why it took a little longer, but I just hope that you enjoyed it. Just in case if you get any doubt, put that into the comment section. I will definitely try to get back to you. Until then, happy learning, wish you very all the best.